I hope all of you are aware of this block diagram. I think this is how the C code get converted, right? Source code, then preprocessor converts it includes the header files and does the pre-processing, and then the compiler comes and then assembly gets executed. What I'm trying to tell you is this linker part of the thing. Okay, in the linker part, what happens is finally, what is the ultimate goal? The ultimate goal is to produce the executable. Okay. So consider you have a hello world program. In the hello world, you are just printing printf hello world. Okay. So everything is fine. But do you know where printf is present? Printf is present in the part of stdlib. Okay. So stdlib has got a set of functions which are defined to perform the standard functions actually. So that std library needs to be linked to resolve the printf call actually. Otherwise, it says printf not found. The compiler fails with printf not found. Okay, but by default, the stdlib gets included in the compiler. That's why you will not get that error. Okay, what I'm trying to tell you is there are some set of code where you have common functionality. You have put the common functionality and inside a code, and you have made it as a book actually. That is nothing but a library. So that printf can be used across many other applications actually. Application 1, application 2, application 3 simultaneously running, which are using printfs. Okay, what I'm trying to tell you is the library is nothing but it's a set of common code which are required by the applications. So that will be linked while compiling. So system libraries, there will be a set of standard libraries, okay, which supports the operating system. I will tell you those things in detail, okay. When you are developing the ARM application, you will come to understand what is a library in detail. So for example, if you see my system, I will just show you. This is my Linux system, okay. I'll go to, I hope all of you are able to see my terminal, right?
Yes, sir.
Yes, sir. Let me increase the font size. Yeah, if you see this, let me search here. So this is the directory which has got the libraries of the operating system. Okay. So in this directory, I will put, for example, consider a sample application where, okay, all of you heard of YouTube Play, right? How the YouTube video will be played back. So when you are playing a YouTube video, there will be many things happening actually. When you are playing a YouTube video on your mobile phone, first it has to download the video from the YouTube server. So the video data will be compressed format because it transfers through the internet, right? It will be in the compressed format. It should take very less bandwidth. So then the audio and the video data should be separated, and then video data should be displayed on the video device, and the audio data should be displayed on the speaker device, and there should be a sync in between them. Okay, these are the complex operations which happens when you are playing a YouTube video. Okay, so for that, what is happening is, for downloading, there will be a library which, see, there is a library called libcurl. Okay, that does the URL handling. That purpose is just to download the links and manipulate the links and upload to the links and all this purpose. That is the library which is specially meant for handling HTTP and HTTPS link. Okay, so so if we develop that library, that common component, instead of YouTube player, another some application can use the same library, the common code, right? So the code size will be reduced. You don't need to write a separate URL handling for application 1, and you don't need to write a separate URL handling library for application 2. We can put it in a common place and call those functions from while you are downloading the YouTube video. Similarly, FFmpeg and other audio libraries will be used while playing the YouTube video. I hope you are getting a decent understanding of what is a library, right?
Yes, sir.
Yes, sir.
Yes, sir. Okay, this is what I wanted to tell you. So library is nothing but a collection of object code which does a common functionality. Okay, so you need the system libraries. So I was in another slide, right? Yeah. Yeah, this is about system libraries. Okay. So the compiler you already know. The compiler is nothing but which translate the code into the machine code, which finally runs on the device. Okay. System softwares. Okay. System software actually they interact with the system. I will tell you in detail. Okay, in the upcoming sessions. Okay. On the user process. So what I'm trying to tell you, these are all nothing but the C functions. Okay. System library is also written in C, C++. Kernel is written purely in C. And then application can be anything. Application can be Java, C, C++, or Ruby, or Perl application, Perl scripting, or something like that. So, for example, how you use can you guess how you can use the system libraries effectively? I mean, in your code actually. libc standard library. libc is a library which has got a printf function. Okay, what you do actually while you are writing the hello world program, you include a header called stdio.h, and then you call a printf, right? Because the printf is declared in stdio.h. So similarly, the kernel will expose some headers, okay, where some functions are declared. Those functions will be included actually in the applications to use the functions defined in the kernel which accesses the hardware. Okay, so application development is nothing but including the header and linking the libraries and writing the code for the applications. So you should have the decent understanding of system libraries. For example, consider if somebody tells you to develop a YouTube player, okay, what you do? So you first will write the logic, okay. I have to download the video and then separate the audio data, video data, and play to the audio device and video device. And if you have a better understanding of the available system libraries, you will write a better application because you already aware of these system libraries are available for this purpose. So I can use them. I can interface those functions. I can interface those. I can include those headers and call those functions. Finally, I will be able to write the YouTube video player. So if you are not aware of system libraries properly, you will not be able to write a better application. Okay, so you should have which library is for what purpose. Okay, so this you will come to know with the experience actually by using those libraries across your development in industrial projects. Okay, so this is about system libraries. So let me go to the next slide. So now you understand the architecture of the Linux, right? The high-level architecture. I think you already know the high-level architecture like kernel, hardware, and these things. So I hope you got some knowledge on system libraries as well. Okay.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay. So system programmers will write the system libraries. So one more advantages of having a library, I will tell you. Okay. Let me go to the blog diagram. Okay. See, one more, the reason why libraries came into picture is, see, for example, after you finish your engineering and you'll go to some domain and you'll start working on some domain, okay. So you will not be able to know everything. Okay, you will be, for example, if you're working in a YouTube player team, where the team is developing a video player for their device, there will be people who has got only codec skills. They are very good in interfacing the codecs and multimedia. That domain is called as multimedia domain. So they are into multimedia domain. Okay, and some people are very good in doing experts in doing the URL handling, HTTP, HTTPS, and secure protocols. So they will develop the URL library. But some people are driver guys, actually driver and kernel guys. They are experts in interfacing the hardware and they are the core embedded guys. Okay, so they develop the drivers and supporting kernel for the device. So what happens is it's an effort of different skill sets actually. So you will not be, see, after 10-15 years of experience, you will not be able to know everything. You will become a domain expert. Like if you go in a multimedia domain, yeah, I'm a codec expert, I'm an MP4 expert. Yeah, so for that reason you will be recruited. So And if you, after some years, if you grow as an architect, you need to have all the knowledge actually, architect for a project. So you need to have all the knowledge and you need to resolve the team's dependencies. Okay, that's how the work flows actually. So what I'm trying to tell you is these codes are developed by each and one experts. Okay, so they contribute that layer actually. FFmpeg guys will contribute for FFmpeg libraries, and kernel developers will contribute for kernel libraries. It's the effort of different people, and finally integrated in the application. Finally, so that makes a product actually. So knowing the knowledge of libraries is very important. I will tell you how to use the libraries in your ARM application. Okay. So, so so what I'm trying to tell you is, if you have a better understanding of open source frameworks, open source libraries, which libraries for what purpose, you will write a better application and easily. Okay. So this is a system programmer's job. And if you want to go in the area of device interfacing and the core embedded domain, that will be like a kernel and driver developers. Those tools are different actually. Yeah, let me start the topic, okay? So all of you are aware, right? What is an executable? An executable is nothing but some piece of file which runs on the CPU, and also it is a series of instruction. So executable will be formed by compiling the source code, okay? So in Linux, actually, there is something called as tool chain. In Linux, there is something called as tool chain. Tool chain is nothing but it is set of application and debugger. You have seen the Keel IDE, right? In Keel, you have the source code. It's a IDE. IDE means it is an integrated development environment, okay, where you have the code editor and debugger and everything integrated in a single tool. So similarly, in Linux, we use something called as tool chain, so which has got the compiler and the debugger. It's integrated, okay. So, have you ever built a hello world application for ARM? Students, am I audible?
Yes, sir. Yes, sir.
Yeah, have you ever built application for ARM? ARM Linux?
Yes, sir. We have. Yes, sir. We have.
Okay.
So ARM
I think.
Linux is not done, but we have worked on Keel.
Okay. I am trying to encourage my.
Linux, they have not worked, sir. Linux platform we have not worked. That is what we want to give the awareness to the students that even through Linux it is possible. They